Hello friends, good morning to all of you, and today we'll learn about polymer chemistry, and this will be very helpful for your upcoming exams, or if you just want to know the concept. I also believe this is very helpful for you, right? So let us start with polymer chemistry, right? So in first of all, in polymer chemistry, you come across a lot of terms, so we will first define those terms. Okay, so you have a lot of ways of defining your molecular weight, right? This can be your number average molecular weight, which is given by Mn. It can be your weight average molecular weight, which is given by Mw, right? It can be your sedimentation average, sedimentation average, which is given by Mz, right? And it can be your viscosity average, viscosity average, which is given by Mv. So these are the four kind of terms we will come across. Four ways of defining molecular weight. Number average molecular weight given by Mn, weight average molecular weight given by Mw, sedimentation average weight, molecular weight given by Mz, and viscosity average molecular weight given by Mv. Now let us look at what is this number average molecular weight Mn. So Mn is equals to summation of Mi, Ni divided by summation of Ni, right? So this is the formula for your number average molecular weight. So let us look at an example and understand the terms that are there. So suppose it's given your, okay, first I'll define all the terms, then we'll look at the example, okay? I think that will be better. So over here we have also our weight average molecular weight, Mw, is equal to summation of Mi squared Ni divided by summation of Mi Ni. Our sedimentation average molecular weight given by Mz equals to summation of Mi cube Ni divided by summation of Mi square Ni, and our viscosity average molecular weight given by summation of, this is the complex formula, summation of Mi 1 plus alpha Ni, summation of whole, okay, not only Mi, and summation of Mi Ni, and this whole thing, okay, this whole thing divided by 1 by alpha, where alpha is equals to 0.521. It's a constant which is 0.521. I will give it to you, right? So a trick to remember this formula which I use is, see, in the end the unit always like comes in m, that is molecular weight. See, over here you have mi, right, and over it's ni. So ni, if you think of units, it will get divided and the unit left will be of mi. Similarly in w, it is like mi square ni by mi ni. So if you think of units, the thing will be left will be mi. Over here also you see we have mi cube ni, but in the denominator we have mi square ni. So the unit that will be left is mi. And over here also if you see, because it's 1 plus alpha, okay, and then over here you have 1 by alpha. So I believe over here also the unit that will be left is of molecular weight, m. So this was the like a formula and how to remember that. Now what it is, what is n? N is the number of molecules. And what is m? M is the molar mass. Okay, now we'll see an example and understand it. Yeah. So suppose it's given that you have to calculate Mn, the number average molecular weight, and what is given is your number of molecules is given, number of molecules, okay, and what is given, your molar mass is given. Okay, great. So number of molecules for 50, their molar mass is 5000, and for 75, their molar mass is 6000. Okay, great. Now it says find Mn. Can you find it out? So let's see how it's done. First we will write down the formula. It is what? It is summation of Mi Ni by summation of Ni, right? So what is N? This is our number of molecules. What is M? It's our molar mass, M. So we know that for 50 it's 5000, so this will get multiplied, 5000, sorry. And because it is a summation, so this part also, the 75 into 6000 will also get multiplied and total will be added up. And what is summation of Ni? Right? It's 50 plus 75. So if you do this, you will get the answer. Okay, I'm not doing it because it's a very simple mathematics. And now we come to the next part. So we will now know about polydispersity index, okay, which is given by P, like Pi. I'm writing polydispersity index. I'm just writing it down. Polydispersity index, which is given by MW, which is the weight average molecular weight, by Mn, which is the number average molecular weight. So suppose if MW is equals to Mn, our Pi will be equals to 1. In that case, it is said that it is a monodispersed. Okay, that means that the size and dimension of the polymer are uniform throughout, right? And we can calculate this polydispersity index via your famous technique known as gel permeation chromatography. Okay, and now we will look at some relation between Mn and Mw and Mz, right? Okay, just wait. Yeah. So for suppose what is the relation, like which is bigger, which is smaller? So there are two cases. One is inhomogeneous, and one is obviously homogeneous, right? Homogeneous. So for homogeneous, what do you expect? You expect that all will be same, right? Mn is equals to Mv equal to Mw is equals to Mz. But obviously not for inhomogeneous. So inhomogeneous, the order is like this: Mn less than Mv, which is less than Mw, which is less than Mz. So a number average molecular weight is lower than the viscosity average molecular weight, which is lower than the weight average molecular weight, which is lower than the sedimentation average molecular weight. How to remember this? If you see N, V, W, Z, this follows alphabetical order. So the later the letter comes, the higher it will be in its magnitude. So let us know some more terms. There are three ways of configuration of a polymer. It can be of isotactic, it can be of syndiotactic, or it can be of atactic. Right. Isotactic means that the repeating units are the same side. So suppose it's a polymer. So an R, suppose R is a repeating unit, so it will be on the same side. Right. So like all have the mold bonds. Syndiotactic means the repeating units are on opposite side. So we have the same molecule, but over here the repeating units will be on opposite. So if this is like in the mold bond, the next one will be in the broken bond. So again the next one will be in bold bond because they have the opposite. Again the next one will be in broken bond. And atactic means there is no pattern whatsoever finding here. So it may be like both like these are the same size repeating units, and the third one is on like the opposite side. And again maybe it's on the same side. So there's no pattern as such. It's random arrangement. Okay. So these are the type of configurations that can be there. Now let us look into an important aspect, which is the degree of polymerization, which is very important from the exam point of view. So let us now look into that. Degree of polymerization. So degree of polymerization, like, and it tells us like to what extent uh, the polymerization has occurred, and the yield for the polymers, to what extent of polymerization has occurred. So for homopolymers, right, it is given by Mn by M0. What is Mn? Mn is a number as average molecular weight. What is M0 then? M0 is mass of single monomer unit. So you're getting the concept over here. So Mn is a number average molecular weight. So it gives the weight of the whole polymer, and this is just for one monomer, right? So if you divide this, like the whole polymer by just one unit of it, so we'll get the degree of polymerization, right? So this is for homopolymers. But obviously you can expect that for other polymers, there will be a slight bit of complexity. So normally for all cases, the degree of polymerization is given by xn, which is equals to 1 by 1 minus p. So this is our degree of polymerization. What is p over here? P is, like I can say, the conversion percentage of monomer. What do I mean by that? It, it means that how many monomers actually get converted to a polymer, right? So the more the conversion, the more the degree of polymerization, right? Because if more monomers get converted to a polymer, it means the polymerization is happening like rapidly. So if like P is more, right? So this 1 minus this, so largest value of P, which can be 1, which is for ideal case, so it won't happen really, right? So it has to be like less than 1. Okay, so suppose it's like very close to 1, right? So this value will be very less. If the denominator is very less, then the degree of polymerization will be very high. Suppose the conversion percent monomer is very low, so it will be like 0.1 or something. So this will be quite high, 0.9, right? So this whole value, because denominator is high, so the whole value will get low. That's why that means the degree of polymerization is less. So you can see the conversion percentage of monomer is high, the degree of polymerization is high. The conversion percentage of monomer is less, the degree of polymerization is less. So suppose we have a 99% conversion, and you're told find x. How will you find? So 99% conversion means you have to write 1 minus 1 minus 0.9, right? Will almost equal to, you can say, 100, right? Also, just for note of exam point of view, I'll tell you that sometimes it's given in this form: k is equals to 1 minus k or kappa. Okay, so this is actually the link average. Link average. Okay, and p is the probability of link. So understanding how it's working, k is our link average and p is the probability of link. Okay, so now we will come to, so I'll just give a question for example purpose, right? So where did my pen go? Question. Question is this, that suppose a graph is given over here, okay, something like this. This is said to be like the molecular weight, and this is our weight fraction, okay. And you're told like there are 4 points over here. There are 4 points, right? And you're told like you have to assign mn, mv, mw, and mz to them. So how will you assign? So I've already told you before, like how this is done. That you have to arrange them, like which is higher and which is lower. And I told you that follows the alphabetical order. So you can easily say it will be something like this, right? Done. NBWZ. So this will be MN, this will be MV, this will be MW, this will be MZ. Now do not get confused. Like you say this is the highest point, this will be MZ. No, this is in terms of the molecular weight, not the weight fraction, right? And molecular weight is given in the our x-axis. So Mz has a higher molecular weight than Mw, which is a higher molecular weight than Mv, which is a higher molecular weight than Mn. Okay, so be careful. So one more concept I'll introduce is the kinetic chain length. Kinetic chain length, right? Which is what? It is equal to your rate of product formation, or you can say, or rate of your reactant deformation. So it's the same thing actually. It's product forming or reactant deforming, right? divided by, so I'll just proper line only, divided by rate of first step, right? So if suppose an example that's given, which says you have to find the kinetic chain length, and the rate of first step is given and the rate of product formation is given. So just apply the formula and you get the answer, right? So yeah, and you see that both the numerator and denominator has the unit of rate. So kinetic chain length will be unitless. Okay, so that's it. So now we will go to an important example. Okay, now like let us look into this example. Okay, let just let me rub this part out. Great. Okay, let us now look into this example. Hmm. So suppose like you guys, okay, so yeah, it's a question. So suppose a graph is given, okay, and over here this is C, which is concentration, and over here eta minus eta zero base. I'll tell you what it is. He is given, right? And suppose this value is given 0.55. This is your 0, and this is 10. Okay, this is 0 point actually 0.055. 0.05. Okay, I think this is good enough, right? 0.05. Cool. 0.55, and okay. So the question is actually quite given in a different way. Okay, okay, let us go with this for the moment. And so it is given that eta, which is our intrinsic viscosity, is equals to K m v alpha, right? And it's given that alpha is equals to your 0.5 and K is equals to 5 into 10 to the power minus 5. Okay, and minus 5. Yeah, and you have to find out mv. Okay, what is eta? Eta is called intrinsic viscosity. Now I'll just tell you some concepts about viscosity. Okay, so eta sp is equals to eta minus eta 0 by eta 0. This is called specific viscosity. Specific viscosity, where eta is viscosity and eta 0 is viscosity, which where concentration is tending to 0. Okay, it's for like C tending to 0. This is not like normal viscosity at any concentration. Reduced viscosity, N reduced, is equals to eta specific viscosity by the concentration. This is your reduced. And you have the intrinsic viscosity, which in specific C and C tending to 0, right, limit C tending to 0 is equals to the intrinsic viscosity eta. Okay, and this is given over here. Okay, and in a specific viscosity, like reduced viscosity, which is tending to 0, is called intrinsic viscosity, and the value of like the value of that you have to find from the graph, right? And like the line that is given is like this. So the value over here that's given is actually 0.05. Like when, so actually there, normally what we know, this is like the origin and it matches and you put like 0 comma 0 over here, but over here it's not the case. Over here like x has this value of 0 and y has a value of 0.05. Okay, so it is not really the same point, so that's why I was a bit confused in the beginning. Now in this, so you have to find out mv, you know alpha is given, you know k is given, so you have to just find out, you know, like your intrinsic viscosity. And what is intrinsic viscosity? It's like the eta specific by c equals to, so I can also write this in the form of like it is eta minus eta 0 by c when limit c tends to 0, and that is exactly what is given over here, right? Eta minus eta 0 by c, and if c is tending to 0, what we get, the value is, intrinsic value is given in the graph 0.05. So this is our value and we know everything, so if we just replace it, okay, and we have like eta over here, and so okay, this will be mv actually because we are finding out mv, this will be k, and this whole to the power 1 by alpha, and we know all the values, right? It's 0.05, this is 5 into 10 to the power minus 5, and alpha has a value given as 0.5. So we just find this out, we get the answer, right? So this is a different kind of example, but if you know something of viscosity, I think it will be helpful. And just one more thing I want to like clarify. If this thing comes, like what is reduced osmotic pressure? Reduced osmotic pressure. So we know that pressure PV is equals to nRT and P is equals to, so P is actually pressure. So you can also like call this pressure at times as osmotic pressure, and this is osmotic pressure is actually given by NV by RT, which is actually nothing but CRT. So this is, you can call it as your reduced osmotic pressure, and this increases with temperature. Yeah, that's it. Okay, next question. So it says like find the probability of link. Probability of link, question mark, when the average value of link, average value of link is equals to, your number one is 10, number two is 100. Cool. So let us find it out. So we know the formula. I have just told you k is equals to 1 minus 1 by 1 minus p, where p is the probability of link, k is the average value of link. That means if the average value of link is 10, this is 1 by 1 minus p. P is what over here? P is your probability of link, which is 0 point, like it is given probability of link, you have to find out, right? So that means you have to just normal substitution, right? 1 minus p is equals to 1 by 10, and that means like p is equals to your 1 plus 1 by 10. Okay, sorry, 1 minus 1 minus 10. This is equals to 10, and 10 minus 1 is 9, so it's 0.9. So this is the answer. Probability of link is 0.9. And similarly, if you have like the average value of link is 100, so this simply will be 1 by 1 minus p is equal to 1 by 100, and that means p will equal to 1 minus 1 by 100, which is 99 by 100, which is 0.99. Right, done. So you can see, like, just know the formulas and you can easily solve the questions. Great. Some, so we have just like one more question only. Okay. So just before we go in the question, you should know like Mn. How is it measured? An instrument called an osmometry. Osmometry. This is used to measure the number average molecular. Okay. You should know it. Okay. And last question then. So it's given, find the average end-to-end distance, end-to-end distance of random coil for 10 to the power 6 monomers. Right. So average end-to-end distance. So it is given with the formula R and like root mean square. Like this is how your average end-to-end distance is equals to root of n into L, where L is our like segment length, you can say, and it's given us like 10 to the power 6. So n is 10 to the power 6. So this is 10 to the power 6 L. So this is like 10 to the power 3 L. So just remember this formula that the average end-to-end distance is given by root n into L, where L is our segment length, which is not given, right? So like total length of the thing, and your n was 10 to the power 6, and when we square root it's 10 to the power 3. So that's our answer, and that's it from polymer chemistry. So from anything comes polymer chemistry should be able to answer it. So there was just some theoretical part left, which is actually quite basic, so I didn't cover that part, which actually says like this polymer comes from these monomers, right? Like you know about nylon 6,6, nylon 6. Okay, so you can easily find out that out from any internet. There's nothing much to understand really over there. All you have to do is maybe just look at some examples and see for yourself where and how it's done. So as an example I can say like your nylon 6 as I just said, right? It comes from your hexamethyl diamine plus adipic acid. So sometimes maybe these things are asked, but not really. Right? And these are very theoretical stuff. So I'm not going to indulge in all these things. Okay, just know that Bakelite, which is very important, right? Bakelite, right? It comes from phenol and formaldehyde plus formaldehyde. Yeah. Okay. And just one quick concept that you should know. It's not really like polymer chemistry, it's like general chemistry, but related to polymers specifically is like your chain growth process. There are actually three steps: initiation, propagation, and your termination. Okay, so initiation is when a free radical is formed. Free radical is formed, and over here there is like, so there's radical is the reactive intermediate. So I'm just writing intermediate, right? So this intermediate plus the molecule will give you the propagation step, right? And the termination is the last step where you get the product, and it removes removal of active center or the radical, right? And is again formed in initiation step, right? Removal of active center, which is a radical. Okay, so sometimes what they do is, so you see like initiation, so this is actually part of the chain growth, which occurs via addition polymerization where radicals are used, and in step growth it occurs via condensation polymerization. So first is initiation when a free radical is formed, which is the intermediate, and then propagation step, this intermediate interacts with the molecule, and the termination step the product is formed, and there's removal of the active center, which is the radical, and again the initiation steps goes on and on until there's this particular end to all the things, right? So that's it, and I believe that covers most of the polymer chemistry. So look at the concepts and practice, and I hope you will be able to answer all the ones. Okay, bye.